So this one, I want to take that region over there on the right, which I'm not going to go over how I get all that stuff. You should be able to do that. You should be able to graph that parabola and find that 3,1 and negative 3,1 where they hit each other. One thing I'd like to point out is that there's a gap. Whoops, there's a gap right here that has a length of 1 going up and down between the bottom of that region, y equals 1, and the x-axis, which is y equals 0. So in most of these cases, especially this first one, I'm going to have to think about that as I'm finding my different, like big R, my little r. So let me draw that. This right here is what I'm rotating it around. So let me draw that in here on my picture. That's y equals negative 2. I'm going to rotate that thing. I'm going to rotate this thing around there. So that means that it's going to show up down here as my like kind of cross-sectional looking thing. So it's going to go like this. These spots are going to be connected. I don't like that. This is going to be connected. This is going to be connected like that. And then the top is going to be connected, but I actually don't want to draw all that because it's going to get in the way. So as it gets rotated around like that, I've got kind of, I want to, wrote this on the study guide, that I want to stick with dx so that I can use this 10 minus x squared thing. You could totally do it with dy, but if I can stick with dx, then I will. So if you think about this, this is rotated, right? If you hold a pencil in the air, try to right now hold a pencil for, would it be sideways or would it be up and down? And you should hold your pencil sideways in front of you, horizontally. And that kind of represents the way that this has been revolved. And imagine taking those dx slices on this thing. You should imagine that each slice's cross-section is going to look like that, where this shaded area that makes it look like a donut would be like that right there, this shaded area, and then that shaded area. So that tells me that I'm using washers. So I know my formula for washers is V equals integral, or pi times the integral of open parentheses big R squared minus little r squared dx. Okay, so now it's a matter of figuring out what the big R and the little r are. So my big R is the length from the top of the parabola down to that spot that I revolved around. So it could be that, it could be this, right? It could be this, it could be any of those things. So those lengths are all dependent on the x value that we're at. So at different x values, that red length is going to be a different length. So let's go off of this one right here. You should see that that's kind of made up of 2 blocks. And you could look at them in several different ways. I'm going to look at them in what I think is the easiest way. The first block is the block from the parabola down to the x-axis. And I know that that is the height of the parabola. So the big R is equal to the height of the parabola, which is 10 minus x squared. And then the next part of the block, in order to, I got this full length, I got part of it, what's left is this down here. In order to get that part that's left, well, that length there is 2. So I add 2. You can also think of it as top minus bottom. The top would be this 10 minus x squared. And the bottom would be the negative 2. So if I do 10 minus x squared minus a negative 2, then it gives me the same thing. So you can do it visually by looking at it, by looking at the 2 different blocks there that make up the larger block, or you can do top minus bottom. If it's a side to side, you can do right minus left. So the next thing we have to do is find the little r. So the little r is this length right here. And you can see, or you should see, that that little r is never actually going to change. It's not dependent on the x value. So I can look at it as the top of it, 1, little r, 1 minus that negative 2 to get 1 plus 2, which is 3. The other way I could do it is look at, well, I've got 2 blocks again. I've got this. So I'm not sure where I was there, but anyway, I've got the little block here of 1, and this block here, that's got a length of 1, this got a length of 2. So I could add the 1 and the 2 to get that full length of 3 as well, instead of doing top minus bottom. So, anyway, now I just need to take, oh, I never simplified that big R. So that big R, maybe I'll rewrite them over here. So big R is equal to 12 minus x squared, and little r is equal to 3. Now all I have to do is sub them into these two spots right here, and then I'm done. So my volume is pi integral, I'm going to bracket it, 12 minus x squared, close, minus 3 squared is 9, close bracket, dx. The last thing I have to do is take care of my bounds integration. Well, I'm doing dx slices like this. So you think about where we're starting with dx. We're starting at that negative 3. Where we end in, we're going to the 3. So I'm going to go minus 3 to 3 like that. Now we're done. So I forgot to put a squared right here. Now it's done.